Welcome everyone. Trigonometry is a branch of mathematics that studies the relationships between the angles and the sides of triangles. So we're going to go over some of just the key topics. Obviously trigonometry is a massive array of topics, but we're just going to go over the key topics in this video. So topic number one is basic trigonometry functions. So for this we're going to be calculating the sin, cosine, tangent, cosecant, secant, and cotangent. So this is the little things that find the different angles. And for this script, I'm going to be importing the math function, the math library. As you can see, it's not accessible. So what I'm going to do here is I'm going to go into my virtual environment, into scripts, and I'm going to activate this PowerShell. And now you can see with this little green header, my virtual environment is activated. So we're ready to rock and roll. We're ready to use these libraries because we're going to be using a couple more later on. So this first one, we got the import math. I'm just going to create just like a basic, we'll type in basic trig function. And here's just like a placeholder. So basic trigonometry functions, we're going to be using the angle radians. So we're going to be grabbing the radians angle. So going to be creating a variable here specifically for this math radians. So this is something that's coming out of the import. And we could change the name of this. We could just put it as radians. We could put it as angle radians, or give it whatever name you want, But I'm just going to have it angle radians like that. Math radians. And now we will return our formulas. So the first one we want to type in is our sin, and sin is going to be math.sin, and we're going to do the math radians like that. But instead of using math radians, we can put in our variable name instead that we're using for math radians. And now I'm going to put in a couple more of these. So I'm just going to do this and then next we're going to go on to our cosecant, secants, and cotangents. So this will also need 3 lines. And I'm just going to write out the first one. So it's going to be the formula for cosecant is 1 divided by math dot divided by the cosine times the radians if math cosine angle radians is not equal to 0. Otherwise, we will convert to a float. And then for this, we'll just do sec. For the secant, we're using a cosine. And for the cotangent, we're going to be using tangent. And now to invoke this, I can create an angle variable where we put in the degrees that we want to use. So let's say we're going to do a 90-degree triangle. And we'll do print basic trig functions. And we'll do basic trig function. And in here, we're going to pass in that angle. So then the way that we want to pass this into here is by using a placeholder for this variable. And for that, I'm going to be using, you can put in any random name you want, but I'll just put in angle degrees. And if you want that to be calculated with your math radians, then you also want to put that same variable into your math degree or math radians parameter. So now if we run this, we can see that for a 90-degree triangle, a right angle it's called, our cosine is 1, or sorry, our sine is 1, our cosine is 6.123, blah, 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 blah. Here's our tangent, here's our cosecant, our secant, and our cotangent. So that's all about the basic trigonometry functions. Next, we're talking about unit circles. These are the relationships between radians and degrees. And we could talk about coordinates of key angles, such as the ones I've listed here. To perform these calculations, I will use once again the math library. And I'm going to go ahead and create a unit circle function. And in here, I'm going to pass in that same variable I created just as we did with the last one. And this also starts off with the same kind of formula where we use the math radians library, or the module I mean. And we're going to be returning. So to get the radians, it's super simple because all we do is use the math radians module, and that just gets you the radians. And then the coordinates, that formula is going to be math. We're going to be using the cosine times the angle radians, and the sine times the angle radians. And same here, we can create the angle variable. I'll put in 30. And we can print out with an F string even, just to mix it up in this video. So we could do unit circle. And we'll pass in that unit circle function with our angle variable that we created here. And this angle variable in the parameter is pretty much just going to go ahead and replace this when we run it. So we can see that this unit circle, the radians is 30. And here are the coordinates. Speaking of coordinates, now we're going to get into the next topic, which is graphing our trigonometric functions. So this is graphs of sine, cosine, and tangent functions. We could talk about the amplitude, period, phase shift, and vertical shift. So for this, I'm going to use the math library once again, and our matplot library. Just like our geometric video. And I'm going to create our graph function. And here I'm going to be generating our x values. So we pass in the x value, which is going to be x times 0.1 for x in range. So this is pretty much like a counter to then specify our range of how big our graph is going to be, which I could put in the dimensions of 0 by 63. So it's pretty much just going to have 64 like blocks in a row. See, if I were to do 0 to 9, then that would be 10. So this graph is going to be basically a grid of 64 blocks. And next I could put in my sin values. Math.sin x for x in values. And then this plots our sin value. And then we will add in our cosine value. And next our tangent value. And next I'm going to be plotting our functions. So here we can create our plot figure size. And onto the fig size, onto our figure, we're going to be plotting our values. So I'm just adding in the x value, the sin value, cosine value, and our tangent value. But the way to do that is we actually have to give it a label. And this label is going to be sin. And we can give it a color, like let's say blue. And we can create a couple more of these. One for cosine value. We can make this color red. And plot, x value. Make the last one for tangent. And for this color, let's try tan. Maybe, I'm not sure if that's a valid color or not, but we'll try it out. It only seems suitable to have a tangent with the color tan. Next, we're gonna add labels and titles. So our first label, we're gonna do an X label, and then we're gonna do a Y label. So it's gonna be our horizontal line and then our vertical line. So horizontal, I'm gonna put in our radians. Then vertical, I'm gonna put in our function value, radian value and function value. And then we can add in a title of trig functions, trigonometric functions, or trigonometric functions, however you want to pronounce it. And then we're gonna plot in our horizontal line, and our vertical line. And we also want to add in a limit for the y-axis, for the vertical line, just as it kind of limits how long lines can be in the graph, just to make it better for visualization. So our horizontal line, we'll put in a color for black, and the line width will be 0.5. And we'll do the same thing for the vertical line. Here are our limitations. And you can play around with the limitations, of course. And I do want it to be a grid, because earlier we were talking about how I want the grid to have 64 squares. So this will put in like the grid lines to make that visible. And I will add a plot legend. And lastly, I will display the plot, so plot show. Now we can call this, so we can do graph function. And now that we run this, we can see we have the function value on the left hand side, and on the bottom we have our radian value. And this is kind of like our graphs being put out, and where all the coordinates of all the lines are. As you can see, these aren't really triangles. So now we move on to the next topic, trigonometric identities. This is where we bring into play the Pythagorean theorem, reciprocal, quotient, cofunction, double angle, half angle, sum and difference, product to sum to product identities. So the first one we're going to get into is the Pythagorean. So we'll do definition, Pythagorean, and we'll add in our angle degrees. And the formula for this is we're going to add in our radians again, as we did in our last equations, the same way. And we need to import the math library if you haven't already. And the return function here, we're going to add the string Pythagorean It's math, the cosine of the angle times the radians, and we exponentiate that by 2. So to the power of 2, or the second exponent, or however you want to say that, plus the cosine times the angle radians to the power of 2. And now if we want to invoke this, we just type in angle, put in 30, and we print off Pythagorean and we pass in this angle parameter and we hit play. Let's try that again. Alright, so we can see the result of this is 1. Next, let's move on to reciprocal. And we'll use the same angle degrees again. So this is a 3-liner for all of the cosecant, secant, and cotangent. And the formula for this, for the cosecant, is 1 divided by sin times the angle radians. So we can activate this by doing the same thing with our angle parameter here, putting in like a 45 and print. We'll use an F string, reciprocal, and pass in our angle parameter. And we can see here are all of our calculations for the cosecant, secant, and cotangent formulas of the reciprocal of a triangle. So next, we're getting into the quotient. Checking, recording. All right. So coming into the quotient identity topic. So for quotient, you have a few different properties. You have the angle of the degrees for which the identities can be verified. You have the angle of radians, which is used for the trigonometric calculations. You have the sin theta and the cos theta. And right here is the theta sign. So here it's showing that, you know, it has a value of 9. I guess. So the tan theta is the tangent with this theta symbol, where our quotient can be calculated. We can also do our cotangent theta calculation with this, and then we can take the tangent of the angle calculated using the math.tan import, which will go ahead and we'll do that first thing. So we're going to go ahead and do the import math. And this module will have, you know, the math.tan, but we're going to use more than that. And we'll just make sure we put in some verifications. So the first one, we're going to define our verify quotient identity. And for this, we're going to pass in a argument, and this we're essentially just going to take this and convert an angle from degrees to radians. So that's what our quotient identity is going to be. We're going to do this conversion. So we're going to take the angle radians, we're going to take our radians, and we're going to use the math radians library, and we're going to multiply that by the angle degrees. And then the angle degrees is what we're going to pass into here, which later on we will use, you know, outside of our function. This is how we're going to use it. We could type in, like, go ahead and type in our angle. Let's say we got a 90-degree angle. And we could type in our results. which we take this, pass it in here, and then in here we type an angle. And of course here we're using this value here, but then when we're calling this here, this angle here gets pretty much passed into this parameter, so this parameter becomes 90. So here we're showing the angle radians equals, we take our math.radians library and we process in this angle 90 degrees into that library. And then from there, we're going to do a calculation. We're going to grab our sin, our cosine, tangent, and cotangent values. And with this, we're going to grab that sin theta. I'm going to make a function for that, where in order to get sin theta, we're going to bring in our math cosine. Or sorry, not cosine. We'll do the cosine after. This is the math.sine. And this is going to be multiply by the angle radians. And then we're going to grab our cosine theta, where now we're going to use that cosine library. And we're going to process it in with the angle radians, which is the value we created here, which again is derived from this 90-degree angle. And then next we can go and grab our tangent and cotangent functions. So I'm going to make a couple more functions here. The first one being the tan function, next one being the cotangent function. And I'm going to grab this. So here I'm trying to create a function where I'm trying to check if two values are equal to each other or not. So for that, I'm going to come onto here to w3schools.com. We got all our math modules here, so I'm just going to scroll down. So after going through this document, I find this one right here. Checks whether two values are close to each other or not. This is the one I'm looking for. Here I'm looking at the example. So I'm going to add in this library here, and I'm going to be comparing the tan theta with the tan function. And here I'm comparing the cosine theta with the cotangent function. And so here, of course, we need to define tan theta and cotangent theta. So for that, I'm going to bring in, so we're going to define these two and avoid dividing it by 0. So we'll do if cosine theta equals 0, then so this block right here is saying the code is manually calculating the tan theta, which is the tangent of an angle. And then after that, we're going to do the cos theta. And we're going to have another theta here, which is the cotangent. So here we're defining the tangent of an angle, and we're using sine and cosine values to do the calculation, and we're trying to avoid a division by 0. So here we're checking to make sure that cosine is 0 before we're calculating it, and if it is 0, it's gonna assign a float infinite. So since the cotangent is undefined, we'll just assign an infinity to it, which can be just like a placeholder. The cotangent of the angle also with a zero division protection error. And then put in our calculation here with the cosine and the sine thetas. And then next we calculate these functions. And our calculations, we're going to use the math.tan for tangent, and we're going to pass in our angle radians. And for our cotangent function, we're going to grab the formula I found on W3 Schools was to grab 1, divide it by the tan function, and if the tan function is not equal to 0, that means we're gonna do the calculation. But if it is a 0, then we're gonna make sure that we set that to an infinity to avoid the error. And then when we're verifying it, we can use this to use the is closed to compare the two. And by the way, of course, this is using a reciprocal calculation method, which is what we just was reviewing before this topic. Within our is closed variable that we're using from the library, we can also add in a tolerance. So I'm going to pass in this tolerance metric that I found that we're able to use with this library. So the reason why we would use this is basically we're comparing these two floating points, and it's pretty much checking if they're close enough to be considered equal. So it doesn't have to be like exactly the same, but we can be close. And then this tolerance is kind of specifying whether or not it's close enough to be considered close in the term of this function. And then what this number here means is the two numbers that we're comparing can differ by up to 1 part in a billion of the size to be close. So we're pretty much saying that we got to make sure that they are pretty much like on the dot close. So we could pass that into both of these. And now in order to return this, we can pass in all of our kind of variables that we want to add our calculations to get the numbers back. So we can grab the tan theta, we can grab our tan theta using math.tan, and that's where we put in our tan function. And then we're going to verify our tangent identity. And for that, I'm just going to grab, I got my variable names wrong. So I'm going to pass in that function there. And our last one is going to be I got these wrong, cot theta, and then I'm going to put this one here as my the verification of the identity. And then finally, to print this out, we could do for key value and results dot items. So that could be in here in our returns. We're going to print out one of our keys and the value of the pair. I think I missed an L in these. Let me run this one more time. Alright. So here we get our tan theta. Our tan theta using the math.tan. Is the identity verified? Is it true? Here's our cotangent theta. Cotangent theta using math.cotangent. And the cotangent identity verification is true. So next we move on to the cofunction. And the cofunction identities in trigonometry pretty much saying that certain trigonometric functions of complementary angles are equal. So the primary cofunction identities are, they going back to the theta symbol. We're going to be using this symbol a lot here again. And we're going to be using a few different tools in here. We're going to be using that angle degrees again, which is the degree in which the identities are verified. The angle radians, which is... So we're going to start off with this import math function, or library, sorry. And we're going to do define, verify, cofunction identity. And in here, this is going to be converting the angle from degrees to radians. Similar to how we started that last one. So it's going to be we're going to pass in that angle degrees. And then we're going to put an angle radians equals the math.radians calculated by the angle degrees. And then we're going to pass in this what's called the complementary angle radians, which is the math.radians of 90 subtracted by the angle degrees. So a complementary angle is angle where there's an angle that has a sum of 90. So here you can see if you had a 30-degree triangle and you added it with a 60-degree triangle, you would have a 90-degree angle. So a 30-degree triangle and a 60-degree triangle, those two are complementary triangles to each other. So coming back to this, so here we're gonna create some of the functions for a angle. So we're just gonna calculate one of those triangle angles. And then after that, we're going to do the same calculations for the complementary angles. So we're going to need a couple lines here. We're going to need one for sin theta, one for cosine theta, one for tangent theta, one for cotangent theta, one for secant theta, and the cosecant. So we're going to do sin theta equals math dot sin angle. Alright, so here the only things I'm going to change is this one's going to be a cosine, this one's going to be tangent, this one's going to be a cotangent, and these are a little bit different here. Here's our secant, and here's our cosecant. And these are all pretty similar. That's 1 divided by its... So for cotangent, we're going to be using a tangent. So 1 divided by tangent. If the tangent does not equal to 0, then it's going to go ahead and do the division. If it is equal to 0, we don't want to divide 0 by 0, so we're going to do that infinite replacement for that. And of course for secant, we're going to do the cosine. And then for cosecant, we're going to do the sine. So these are our trigonometric functions, and now we're going to do the same functions for our complementary angles. So up here, I'm going to type this in. These are our trig functions for the complementary angle. 1, 2. So for here, we're also going to do the sin complementary equals okay, so then here we just replace sin with cosine. Then next one we replace with tangent. These ones we just leave as is. They all get processed with their complementary angles. And then here we're going to do our cotangent, our secant, and our cosecant. And now these ones here, like the division, so we're going to be dividing this by the tangent complementary. If, of course, the tangent complementary is not equal to 0. Otherwise, we're going to replace that 0 with infinite. And then this is where we're going to verify all of the results. So we're going to verify our identities. So we're going to put in our results. Then we're going to put in our first one, which is going to be the sin, which is going to be 90, take away 0, is equal to cosine. And this is where I can stick in this. So it's actually, so we're going to do x. And we'll do 90 degrees, take away. We'll put in this sign. This is not a 0. This is our theta. So 90 degrees take away theta equals whichever angle we're looking at. So I'm going to do the angle times theta again. And we're going to do math is close to do the comparison. And we're going to put in our x complementary, whatever the angle is. And we'll put in our angle theta. And we'll put in our tolerance. Make sure that the comparisons are pretty close. And of course, so here's where we come in and just replace x with sin. Then here we return our results. And then just like last time with the usage, we'll grab our angle with the results, which are going to be, I'm going to be grabbing this variable here so we could pass in this angle degrees. And then with our angle, we could put in whatever degree we want. So we could do like 30 degrees this time. And then we could put in our for loop. So for identity, for all of our verified identities in results, in each item in results, which means like you know, this is each item that's going to be in the results. We're going to print out the key pair of the identity and the value, which is our verified identity, if it's verified. But if it's not verified, we're going to put in not verified. So it's going to print verified if it was verified. If it's not verified, we'll put in not verified. So here we can print this. Line 16 right here. I missed the N. Okay, line 32. What do I got on line 32? Right, I gotta pass in the cos. I got my math all messed up here, and this one's got to be tangent. No, this one is not tangent. This is sine. All right. Okay, so none of my results are verified, so that's not good. Can we at least see what the values are though? Like if we could do for key value and results items, could do a print f key. Let's do our key value pair, see what this brings out. We hit play. They're all false. And then what if I change this angle to 90? So anyways, moving on to the next topic is the double angle. This one I've actually been stuck on, and it's the reason why it took me 3 months to upload this video. I'll be honest, I could not figure out a script to calculate this. So I've skipped to half angle, which I also have a script that's similar to my co-function where I wasn't really able to figure out how to make it work. But I got a little something for it, so I'll quickly go over it before going over the last two. So let's get into the half angle, which this is pretty much identifying. So here is kind of a chart showing the difference between an equation from half angle identities to double angle identities. And you know what? I'm gonna have to save this one for another video. I'm still trying to wrap my head around this, and I'm still doing practice runs, writing this on pen and paper, trying to get my skills down and my comprehension down. So at this time, I cannot talk about this subject. So I'm moving on to sum and difference. So these are the identities that are used to express differences of angles in terms of the functions of the individual angles. So this, we'll use our math library, and we're going to define our verification of the sum and difference identities. And for this, we're going to need a couple angles, right? So this is going to grab two different angles. We can get angle B, but we're going to do degrees and radians, right? So we're going to do degree B. What do I want to call it? B degree? I don't know. And then we'll do A degree. So we got B degree and A degree. All right. And this is going to be converting the angles from degrees to radians. So we're going to grab the A radian, which is math radians, pass in our A degree. Then we're going to put in our B radians with our math.radians, pass in our B degree. Now we're going to calculate the functions, right? We're going to string function calculations. So we'll do the whatever angle A. We'll do math dot whatever angle we're calculating of the B angle. Sorry, the B radians. So now we're going to put in our angles. This is going to be our sine, our cosine, and our tangent. Sorry, I got this backwards. Sine A, cosine A, tangent A. And these are actually going to be our A radians. Put an S there. And then here we're just going to do the same thing but for the B. And here we're going to do a calculation for the sin, which is going to be the A angle. And we're going to pass in this plus minus. So this means that we're specifying that it's going to add it first and then it's going to subtract it after. So that's kind of how we want the PEDMAS hierarchy to go. Put plus first and then minus after. So here we're going to be putting in sin A add B. So we're doing a sin A add B. And then we're doing a sine A minus B. So we're doing our addition first and our subtraction second. So we're going to do math.sine times the angle, the A radians, plus B radians. And this is going to be math.sine A radians minus the B radians. And then we're going to do the same thing for the cotangent and the same thing, or sorry, cosine, not cotangent. And the same thing for the tangent. So for the cosine, we're going to put in the cosine A plus cosine A add B with the math.cosine A radians plus the B radians. And we're going to cosine A subtract B. And we're just going to copy paste the same block down in the tangents. And we could put in our another function here for the sin sum identity and the sine difference identity. So here are two identity to calculate. So the first one is going to be sine A times cosine B plus cosine A times sine B. And our next one is going to be sine A times cosine B minus cosine A times sine B. So we're going to grab this same function and add it on to our cosine. We're going to add it on to our tangent. So here we're doing cosine. That's this calculation. So we're just, so in the sine we got sine, cosine, cosine, sine. Sine times sine A times cosine B plus cosine A times sine B. And then the cosine sum difference is going to be cosine A times cosine B plus sine A times sine B. And then with our tangents, we'll put in our tan summary, or our sums. And we're going to do tan A times tan B. Wait, going back to here, the cosine is times, and this is actually a minus. And then the difference here, we're going to be adding it. So that's the cosine. And then the tangent, we're going to be, it's a division. So it's going to be tangent A times tangent B divided by 1 minus cosine, 1 minus tangent A times tangent B. And we'll put these into parentheses like this. And then the difference in the tangent identity is going to be tangent A times tangent B with 1 plus after the division. And then next we're just going to do an identity verification with the results parameter. So put in our angle, it's going to be A something B. It's not times, I'm just putting in a placeholder. We're going to do an angle for A, another angle for B, plus angle A with the other angle of the B. And we'll do math is close. And we'll flesh that out. So just kind of making this, the first one we're starting with the sine, right? So we're doing sine, and we're doing addition. So sine A plus B equals sine and cosine plus our cosine and sine. And the math close is going to be comparing the sin A add B with the sin subtract B, and we'll put in our tolerance to just make it on point. Our next item here, we're going to do so with our addition, we're verifying our sum identity. And then the next one, we're verifying the difference identity. So this is just going to be the opposite of the one above it. And this one is going to be a minus here. All right. So it's going to be sin A subtract with the sin difference identity, and we'll put in the same tolerance. The next one, we're doing our cosine with our cosine sum, and the next one underneath it is going to be the opposite, which is the cosine differentiator or difference. So we'll do cos A, cos B, and that's going to be plus, or sorry, minus sine. So it's going to be cos A add B. This is going to be the cos sum identity. The next one's the opposite of the one above it. It's going to be our cosine. And this is going to be cos A subtract B with our cos difference identity. And next we move on to the tangents, where we get into, so this is where we get into the division on both ends. And then the only difference being on this one, it's 1 minus, and this one is 1 plus. So we add these parentheses in here. And the way we check this is just doing the tan A add B, and the tan sum identity. The next one we're doing tan subtract B with the tan difference identity right here. And upon returning the results, we also still need to calculate the two angles. So we need angle A and angle B. And let's say angle A is a 45-degree angle. Let's say angle B is a 30-degree angle. And our results are going to be verify some difference ID. We're gonna pass in our B angle with 30 and our 45 because that's kind of how I wrote it up here. And then for identity, verified in results, or you know what? I'll just do that key value pair that we used in the quotients. So for key value and results items, we're gonna print out the key and the value of the pair. So here, if I hit play, hopefully I don't have too many errors. And here we can see these are true, these are false. Let's see if there's any difference if I change this. If I put a 0 on one angle, 0 on the other angle. So there we have it. We have our sum difference verification. And then finally we have our product to sum and our sum to product. So we can move on to the product to sum or sum to prod. And for this we could pretty much use this same script right here. We just add a couple things onto here. So I'm gonna make a new. So this is another one of those subjects that I'm gonna have to come back to. I don't really completely comprehend this one. So for the time being, I'm just gonna leave the video at this. You know, this was I definitely struggled a bit studying these trigonometry topics and getting the concepts down, comprehending it, trying to make a Python script that would kind of do something related to it. But that's all I got for this video, and I'd like to thank you guys for watching.